at ellipses. Ellipses are the next type of conic section where you would have the plane that's cross-sectioning your conic section at a tilt. Your circle was perpendicular to the surface that it's sitting on, or I'd say perpendicular to the axis of your cone, but this one's going to be skewed a little bit or slanted. So that's how you get an ellipse. A couple things that we want to point out is in astronomy, you might talk about a major and a minor axis. Okay, so major axis and a minor axis. We're not going to be concentrating a whole lot on these terms because we're really looking at solving the standard form of equation and getting our information out of that. But all you have to do is double your A or double your B, and then you can actually find the measure of those if you need them. All right, let's go ahead and also define a couple terms. On the end of your elongated side is going to be what we call a vertex, and that's mirrored on the other side as well. On the short side of your ellipse is going to be a covertex, and that is also mirrored on the other side. We also have the center of our ellipse, but we have another new part now, which is called a focus. And that's a reference point where there's some measurement that can happen to get us a constant value. The other piece that we need to know is that there is a name for our elongated radius or longer radius, and that's called A. And then we have a name for our shorter radius, and that's B. Please note that your A is always, 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 always larger than your B. That's how you can tell if it's a horizontal or vertical ellipse. Ellipse. So here we have what I would call a horizontal ellipse. And the way I know that is because it's elongated along my x-axis. You can also have what we call a vertical ellipse because that's elongated along the y-axis. Let's examine our equations and go ahead and take a look at what these mean. We're going to start out very similar to how we would in our circle equation, but we do have a little bit of a complication, which is our denominator. If it is a horizontal one like this, we have an a squared in the bottom there and a b squared on the bottom here. Now remember, we're getting these values as our elongated and shortened radii from our ellipse. Both of these add up to equal 1. We also have a vertical version. This also has a vertex on the elongated side, also has a covertex on both sides, still has a center, still has a focus, and those are mirrored, of course, on the other side. And then we have the elongated side, which is actually here, and then your shorter side is here. So this changes our equation that we have. So even though it's still the top of our equation looks the same, we have a difference where b squared is under x and a squared is under y, and that's going to be equal to 1. Again, a is going to be greater than b, so that's how we're going to decide if this is horizontal or vertical. We also use the same strategies that we did before to find our center. So our center is located at HK. All right, let's go ahead and take a look at an example. I'm going to skip this first one and go to this second one just so that we have one that's a little bit more standard. This is going to take one more step for us. I'm looking at this and I'm going to go ahead and fill out this as we go. So my center is based on what's happening inside my parentheses. So x minus 3 means that I have an x value of 3 as my center. And then the minus 5 means I have a 5 as my center. So 1, 2, 3, 1, 2, 3, 4, 5. So this is my center of my ellipse. Well, which side has the bigger number? I can see very clearly that 49 is a larger number, and so that's going to be a squared, and this is going to be b squared. if I want to go ahead and find my values of a and my value for b. So if a squared equals 49, then a is going to equal 7, or the square root of 49. B squared here equals 4, so that means that b equals 2. These are important numbers because they are our larger and smaller radius of our ellipse. We know that my x side is larger. That's where my a is located. So that means I'm going to count from left to right 7 on each side. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And these are my vertices. So to map out those vertices, I'm going to go ahead and I have 3 here, and then the addition of 7 is going to make it 10, and I'm at 5 high. I'm at 3 in my center on the x. I subtract 7, and that's going to give me -4, and I'm still at 5 high there. So 10, 5, and -4, 5 are my vertices. Now I'm going to go ahead and count out my co-vertices. Those are based on b. So I go from my center and I count down 2, and then I count up 2. And those are going to be my co-vertices. Let's go ahead and map those coordinates out. So the first co-vertices is 3, 3. And then the second co-vertex is 3, 7. And then the last part is to find our focus, but I'm going to go ahead and connect this. It's a little bit difficult to draw an ellipse, but we are going to connect essentially all of our vertex. Sometimes it looks more like a disc than an ellipse, but we're going to do our best here. So that's what it looks like. Now to find our focus, we're going to use c squared is equal to a squared minus b squared, and those conveniently are already located here. So we have c squared equals 49 minus 4, and that will be 45. So c is equal to the square root of 45. Now with this, you're going to want to go ahead and calculate this into numbers so that it's easier to graph. For those of you who are planning on taking calculus next year, you definitely want to go ahead and do this to a full 3 digits. So the square root of 45 is going to be approximately 6.708. 6.7 is fine if you're in regular pre-calculus. So in order to get that, because this is horizontal, I'm going to take that x value, which is 3, and I'm going to do x plus 3, or I should say 3 plus my foci, so 3 plus 6.708, and then I'm going to do 3 minus 6.708, and that's how I'm going to get my 2 focuses. And so 3 plus 6.708 is going to give me an x value of 9.708, and that's going to be at a height of 5. And then my other is going to be 3 minus 6.708, which is going to be -3.708. So those are my foci as far as the coordinates are concerned. Something that is that close is going to be almost on top of the thing. So it's a little bit difficult to graph there, but do your best with what you can. All right, let's go back one, and we're going to check out this one. This is kind of interesting because we don't have our normal standard form that we're used to seeing. We can get it that way because we know we want it to equal 1. And so in order to get it to equal 1, I have to divide all parts by 25. When I do that, that marks out those get canceled and these get canceled. So I'm left with x squared over 1 plus y squared over 25 equals 1. So my center, because I don't have a shift on my x or y, is going to be 0, 0. So that's a pretty easy way to look at it. My a value or b value, I need to choose from the denominator. This one right here is a squared. This one right here is b squared. So a is equal to 5 and b is equal to 1. That means this is going to be a vertical ellipse. So I'm going to count up 5, 1, 2, 3, 4, 5, and count down 5. And those will be my two vertices. So 0, 5, and 0, negative 5. And then I'm going to use B to figure out my sides. And because I have 1, I'm just going 1 away from my center. So those are going to be 1, 0, and negative 1, 0. And now I can go ahead and draw my ellipse. So it's going to be a skinny one that's vertical. Now the last part I got to do is go ahead and find my foci. So c squared equals a squared minus b squared. So I have 25 minus 1. That's going to be 24. And so c is going to equal the square root of 24. And we're going to go ahead again and put that in our calculators. And a reminder to those of you who are taking AP calculus that you do definitely want to do it to 3 decimal places. So the square root of 24 is 4.899. For those of you in regular pre-calculus, you can go ahead and use 4.9 as your number. So from here, what I'm going to do is add it to my y value from the center, because my focus is going to be towards the end. So whatever that value, that 4.899, is going to be added to 0, and then it's going to be subtracted from 0 on my y. So each of those foci is going to be 0, and then 4.899, and then 0, negative 4.899. Notice that where your foci are located is really dependent on whether this is a vertical or a horizontal ellipse. All right, now it's time for you guys to go ahead and do some more practice, and we will get back to our review shortly.